If you look at job descriptions today, the titles for infrastructure roles are completely tangled. You see DevOps engineer, SRE, cloud engineer, platform engineer, production engineer, all used interchangeably. So while the broader industry is all confused, big tech is making a very deliberate change to clear a lot of things up. They are moving away from the standalone ops or SRE roles and are replacing them with software engineer infrastructure or software engineer site reliability. Now, this is not just a fancy rename, it's a signal that the industry is telling you we don't want operators anymore, we want engineers. So, if you are someone who want to transition from a DevOps role to a site reliability engineer role, you need not build stronger muscle in Kubernetes or learn another tool. You just need to adopt the software engineering mindset. For a long time, DevOps was often treated as a role for people who are good at tools. CI/CD, Terraform, Kubernetes. But SRE isn't about tools. SRE is what happens when you treat operations as a software problem. This means we stop trying to fix infrastructure manually and we start writing code to manage it. Here is my perspective. The difference between a DevOps engineer and a site reliability engineer is not knowing a tool better. The gap is computer science depth. To make the jump, you need to stop acting like a system admin and start acting like a systems engineer. To bridge this gap, you need to add 3 specific pillars to your toolkit. These are the non-negotiables for the software engineering title. The first pillar is coding. Yeah, you can't escape it. In DevOps, we often write scripts to glue things together. In SRE, we build the glue. You need to move beyond the 50-line bash scripts. You need to write structured code in Go, Python, or Java. You need to understand data structures, concurrency, error handling. You aren't just running a script. You are building a scalable product. The second pillar is internals. An operator knows the command to restart a server. An engineer knows why the server crashed. Was it an out of memory kill, a file descriptor leak, a zombie process? You need to understand Linux internals and networking, like TCP/IP, DNS, to debug the root cause, not just a symptom. And the third pillar is system design. And this is usually the biggest blocker. An operator deploys a load balancer because the documentation said so. An engineer chooses the load balancing algorithm based on the traffic pattern. You need to understand distributed systems, caching strategies, database sharding, cap theorem. You are the architect designing for failure. Beyond the code, there is one massive mindset shift. Monitoring versus observability. Monitoring is reactive. It asks, is the system broken? Red light or green light? Observability is investigative. It asks, why is the system behaving this way? As an SRE, you care about SLIs, SLOs, error budgets. You use data to make engineering decisions like freezing feature launches to protect reliability. It's true. That is the difference between maintaining a server and engineering reliability. So here is your action plan to make the switch, or at least be ready for it in the next 3 to 6 months. Focus on logic. Stop scripting. Pick Go or Python. Solve 1 to 2 lead code problems a day. Build a CLI tool. Don't just write a script. Next, focus on internals. Deep dive into Linux. Read the Google SRE workbook. It's free. Understand how the OS manages resources under the load. And lastly, focus on architecture. Study distributed systems and learn how to design for 5 nines of reliability. There are n number of YouTube channels who are teaching you system design, who are taking mock interviews of system design. The industry is moving. The DevOps title might stay, but the expectations are becoming purely engineering. Don't get left behind as an operator. Become the engineer who builds the platform. If you get stuck in any of the mentioned steps, drop a comment below or connect with me on LinkedIn. Let's get to work.